Good morning, everyone. My name is Kelly Kane, and I'm the Marketing Manager for Wonderware NorCal. Thank you for attending our webinar today, where we will discuss how Wonderware and Thermo Systems helped a plant earn several sustainability awards by saving 2 million gallons of water annually and being 33% more energy efficient. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or email us at webinar@norcal.wonderware.com. Now I'd like to introduce your presenters for today's webinar. Your first presenter will be Wonderware NorCal's product specialist, Mike Lapitan, and your second presenter will be Corey Nataro, a business development manager from Thermo Systems. So now let me go ahead and turn it over to Mike. Good morning, Mike.
Hi, good morning, everyone. Thanks for joining us for our Friday webinar on how System Platform powered an award-winning pilot plant. And we've got a guest speaker today from Thermo Systems, Corey Nataro, as Kelly mentioned. So we're really excited to have him present on the project that they implemented. So our agenda today is we're going to take a brief look at Wonderware in the marketplace and look at what System Platform is from a high-level overview and some of the differentiators and the value of System Platform and how that was applied then to a success story at a validated pharmaceutical plant. So Corey will share the project requirements and the customer's goals and how they were able to realize those goals and get value from System Platform in running their validated pharmaceutical plant. So Wonderware Today is used in a third of the world's plants and facilities, and that equates to over 150,000 locations. So it's the #1 HMI software product on the marketplace. Been around since 1987, and when we talk to customers who are investing in a SCADA system, they want something that's proven, it's been around a long time, and they know that it's going to be around for the future. And so Wonderware has the best track record in the marketplace. And we are also the lowest risk SCADA solution, being the easiest to use and the best supported. You could have an original Wonderware application, 25 years old, and migrate that today to the current version without having to rebuild. And that includes support for Windows 10 here later this year. We've got 3,500 system integrator partners globally, and Wonderware is very flexible and allows you to start small and grow over time and add functionality as your business requires. So we'll show you what kind of functionality you can add to the System Platform. Wonderware NorCal, we've been your local resource since 1992, and we offer local training out of San Francisco. Training is also offered in Southern California at the Wonderware Development Headquarters in Lake Forest, and we can also come on-site to your location and bring the training to your site. We offer free San Francisco workshops, and we can do those on-site at your location as well. And in fact, we've got a workshop next week, and I'll show you our website, and you can register for that. We've got an InTouch workshop, and we have local technical support, system consulting, and sales. And here in Northern California, we work with about 70 registered system integrator partners to help you with your projects. We get great feedback in the field about our tech support, folks that are very knowledgeable, been around with us a long time, and it's very important to our customers that if they have a technical question, a development question, they can get somebody on the phone who can answer their question right away. And our customers really value that. And so we're really proud of our tech support staff here at Wonderware NorCal. They do a great job. So some highlights of System Platform. It is a platform for plant-wide data collection, monitoring, control, and analysis. So that's your basic SCADA functionality, supervisory control, and data acquisition. But on top of that, System Platform differentiators include advanced alarm management. So Wonderware gives you a lot of best practices out of the box to make sure that you're using alarming in a manner that doesn't overwhelm your operators with alarms to the point where they start ignoring them. So there's been a lot of best practices written around alarm management, and Wonderware's incorporated that into the product. Very big differentiator for us. Situational awareness graphics is a graphical library that's included free with System Platform and InTouch, and that's a graphical library that again leverages best practices for building effective operator HMI displays. So again, when we look at industry experts who've written best practices on building operator HMI screens, we now give you a full graphical tool set to use out of the box to leverage all of those best practices. And I'll show you a demo of that here shortly. The Wonderware Historian is a key part of the system platform for storing the records of your process, so you can go back in time and see what you did, how you did it, and so if you have an issue, you can quickly see that, troubleshoot it, and quickly resolve it, as well as satisfy reporting from production reporting to regulatory reporting. And we have out-of-the-box store and forward redundancy for the Wonderware Historian, meaning if the historian goes down for any reason, planned or unplanned, the system platform automatically collects and stores that data and buffers it and backfills the historian when it comes back online. So again, a very big value add for our customers. And you can add functionality to the system platform. We'll talk more about that. The security is very, very robust in system platform. That's very important for our customers. Native integration with Active Directory, but beyond that, being able to drive roles associated with your users and groups. So who has privileges to go into development and change things? Who has the ability to go into runtime and change operational parameters, change set points, turn things on and off. So the security model behind system platform is very robust. System platform allows you to organize your plant data into a model that helps you organize your data, and it also helps in when you start adding additional manufacturing execution functionality to leverage that plant data model. And you know, when you need to do a report against something that's manufacturing related, having a plant model to report against is extremely valuable. I'll talk a little bit more about that. System platform is a reusable object-based development environment that allows you to enforce standards and drive change management. And Corey's going to talk quite a bit about this component, is why Wonderware was selected for this project, because it really reduced the time to validate the system using standards and template-based development. And system platform uses .NET, the .NET framework for the automation world. So that means if you need to do custom integration with databases or third-party software applications, you have the .NET framework available right inside the system platform to you. So let's take a quick look at a demo. Again, the Wonderware vision is to integrate and improve disparate systems. So inevitably, in any given plant, we've got lots of different PLCs and control systems that have come in over the years from different vendors and OEMs, and Wonderware is really good at integrating all of those different data sources and providing a unified system for your operations so that you can effectively run your plant, increasing efficiency, increasing reliability and safety. So let's take a quick look here at a demo. And what I'm going to do is I'm just going to go to a web page, and this is I don't have any Wonderware installed on my computer. I'm just going to a web page, and I'm going to connect to my InTouch application. So I'm going to click Connect. So I'm accessing InTouch, which is the visualization component of System Platform, right from a web page. And so this is what you can do in your plant. And obviously the server that hosts the web page would be on-premise at your facility, so you're not exposing your control system to the outside world. But now I've got my situational awareness dashboard here. I'm looking at my different filters, and I can drill down into a specific filter to see what's going on. So I can see that I've got some alarm borders here, so I've got some high levels. I can see I've got my situational awareness trend pens here, so I can see what I've been doing over time. If I'm staying within my target region, I can see I've got a turbidity event here. So these are alarm borders. And then if I want to then operate my plant here, I can drill into the operational HMI and see my traditional HMI screen to operate the plant. Okay, so again, these are graphics that come out of the box with System Platform. This is an OEE type dashboard where I'm looking at my uptime, downtime over the last 8 hours by line here. And we've got a lot of new charts and trends that are very lightweight, encouraging you to really have an effective operator HMI to see, you know, where you might be deviating from your targets and keep production running on track. So I wanted to point out we do have a free workshop. I'm at norcal.wonderware.com. It's our website. If you go to our workshop schedule next week, September 16th, we have an in-touch, hands-on workshop. We've had a few seats available left for this, so I'd encourage you to sign up today before it fills up. We are actually going to create an in-touch application, and we are going to connect to a PLC. We are going to use the situational awareness graphics, and we're going to create the alarm borders. We're going to look at some of the new functionality with the tag viewer. We're going to use the Wonderware Historian trends. So this is a completely hands-on class. It's a one-day free training on Wonderware InTouch. Come to San Francisco. We will feed you and educate you, and really be worthwhile. So we're excited for that event next week. Hope you can join us. So the system platform components consist of the application server, which is kind of the development environment and the execution environment of the system. And the Wonderware Historian is the process database for collecting and storing all your historical data, so you have a history of what you did. And an information server is a web-based component allowing you to have web-based reporting. And then the device integration server component is the PLC connectivity, the controller connectivity to your real-time data sources. So those are the basic components of a system platform. And then you have clients, including InTouch, which is your operator HMI or supervisory dashboard HMI. We have Historian Client, which gives you real-time historical trending, very user-friendly and powerful trending. And we also have an add-in to Excel, allowing anybody to easily pull historical information into Excel for reporting purposes. And we have web-based client licenses as well. Okay, so another differentiator with System Platform is we create our objects that typically represent a piece of equipment. So in this case, I've got an example of a valve. And so my valve object would include where is the I/O coming from, where's my controller, any graphics associated with this valve, any alarms and events, security who has access to this valve in terms of development and runtime operational permissions, historical information. If I want to add a valve attribute to my historian, I literally just check a box and it automatically adds a tag to the historian, as well as any logic or scripting associated with this object. Okay, so system platform development begins with an object, and then you can create templates from these objects. So if we start with that valve object, and then we've got maybe two different types of valves, an inlet valve and an outlet valve. So I can create a derived template from my parent valve, and an inlet and outlet, they inherit everything from their parent valve object. And then I've got runtime instances of my inlet and outlet valves, and they also might have unique attributes to them. And so what this means is if I ever make a change to my parent valve template or an inlet or outlet template, I can drive those changes and force those changes down to the children instances. And Corey's going to talk about how that helped decrease the engineering effort and time in designing, developing, commissioning the control system, and validating the control system. And I mentioned Wonderware has a plant model, and again, this is a big differentiator for us. And what it does, it allows you to organize your data based on your physical plant in your areas. So this helps with alarming, as I want to see alarms by certain areas. This helps with structure and organization, so I can quickly find the development templates or objects that I need to work on, and it helps on the reporting side. If I want to do reports or dashboards, I can look at, for example, if I want to do traceability, I had a work order and I was making a piece of product and I want to track all the different pieces of equipment that product ran through. Having a plant model allows me to do that. Same thing if I was going to do OEE. I want to look at overall equipment effectiveness for maybe individual pieces of equipment, but then the line as a whole. So plant model allows you to do this. So system platform is a true manufacturing platform. It connects to anything. It gives you a plant model and a historian, a visualization with InTouch and web-based access to this information. And then you can plug in functional modules as you need, whether that be OEE for performance, material tracking and genealogy. That's our MES operations module for track and trace. And if you have a batch operations, we have an in-batch module that plugs into system platform. We have a quality module for doing your sample plans and SPC. If you need to integrate with a maintenance system and do runtime hours driving maintenance activities or different alarms and conditions driving maintenance work orders, we can do that. Mobile inspections, we have mobile tools. Energy management, Wonderware, was acquired by Schneider Electric, and they are very good, a lot of expertise at doing energy management. So everything from metering to software for monitoring energy quality, energy usage, and helping you reduce energy costs and increase energy efficiency. And on top of that, we have intelligence dashboards and a data store, and that can integrate with external databases as well as the Wonderware databases. And we have a workflow engine as well, and workflow ties people in with systems. So if people need to get notified, for example, if an operator needs to make a set point change and they need to get permission to do that, they can make the request right in the HMI. A supervisor would get a notification, whether it be email or a text message or something that pops open in their inbox in Outlook that says, hey, there's a set point change request. They can approve it right there. The operator gets feedback that says this request has been approved, and then they can move on. And the workflow includes forms as well. So any forms that need to be made electronic, going from paper-based, now you have electronic audit trail of events and forms and who did what, when, and how long it took. Okay, so Wonderware is a manufacturing platform, starting with system platform for your basic SCADA application requirements, and then adding manufacturing functional modules on top of that, and integrating with enterprise systems such as your ERP accounting systems, your asset management maintenance systems, laboratory systems, warehouse management systems, and then we have workflow on the side here that can really integrate the people with the processes. So with that said, I'd like to turn it over to Corey.
Great, thank you, Mike.
Mm-hmm.
All right. So Corey, you should have the presenter role now.
Yep.
You just need to share your screen. All right, we can see your screen and we can hear you.
Okay. How you doing, everyone? My name is Corey Notaro with Thermo Systems. Talk to you today a little bit about a good pilot plant that happened in Pennsylvania that we utilized the Wonderware software for. So thank you, Kelly and Mike, for bringing this webinar together. Yeah, I'm going to leverage a lot of what Mike had to say because it definitely helped in both the design and implementation for the SCADA systems that we'll talk about today for this pilot plant. So I'll jump right into it. So just a quick agenda. We'll do a quick overview of Thermo Systems, our history, our capabilities, what we do, are we good at it, some of our engineering team, and then we'll just jump right into the project. So we'll do a quick customer and project overview, some of the timelines and awards that were given out for this great facility, some of the initial design concerns from one of their existing plants, and then really what played a role into the selection process for the new control system. Then we'll go into some details and screenshots of the SCADA systems, and then we'll really drive it home with the customer feedback and why they value the system so much, really how it helped them really perform well. So Thermo Systems is a design, build, control systems engineering and construction firm. We manage and deliver turnkey projects serving as the main automation contractor, or MAC. So some of the services that Thermo Systems provides is automation and instrumentation and controls design, panel fabrication, assembly, and testing, systems integration and programming, both PLC and SCADA, turnkey instrumentation and control, electrical and mechanical installation, startup commissioning and validation support, and then another arm of our company supports the complete life cycle of facilities with 24/7, 365 on-site and remote support. Some of our established locations are spread out all across the country. Our original location and our headquarters is in East Windsor, New Jersey, along with our facility in Pittsburgh, Pennsylvania, West Point, Pennsylvania, Denver, Colorado, Henderson, Nevada, Long Beach, California, San Francisco, California, and our new office in Austin, Texas, to support some of our work that's going on down in that area. So just to give you some of our industry affiliations, we've had a long partnership with Wonderware. We're certified systems integrator partner with Wonderware in both system platform and InTouch. Also, some of our other industry affiliations include CSIA, where we're level 1 certified, International District Energy Association, or IDEA, and then some more familiar ones such as ISA, ISPE, AEE, and aside from just partnering with Wonderware, we also obviously have had a long-standing relationship with Schneider Electric and the Modicon line. Our industry experience varies from industry to industry in different verticals, but we really focus in on some of the regulated industries, chemical manufacturing and processing, and utilities. So utilities going from combined heat and power, also known as CHP or cogeneration, chilled water plants and optimization of existing chilled water plants and boiler plants. Those regulated industries I was talking about ranges from validated life science manufacturing applications, validated and mission critical data center or any real industrial and critical HVAC building controls. And then some of the step-down regulated industries such as food and beverage, consumer packaged goods, and then also chemical and manufacturing process applications. To give you a little background of our engineering team, we have a very, very wide array of engineers, and they go from electrical, mechanical, chemical, marine, computer systems, and computer science professionals. We have our IT department that includes CCNA engineers along with ISA cybersecurity certified engineers. We have 5 or 6 licensed professional engineers on staff and a handful of INC technicians that support our on-site startups and anything from our 24/7, 365 service to field calibrations. Some of our industry certifications include Certified Energy Managers, also known as CEM, ISA Certified Automation Professionals, also known as CAP, Project Management Professionals, PMP, Certified Network Engineers, CCNA, ISA Cybersecurity Certified Engineers, and NIST Level 2 Technicians. And actually that picture on the bottom right there is 2 of our directors in our engineering departments actually on the customer site that we'll be talking about today at one of the point of use panels. So a quick overview of the project. The company is called Morphotek Incorporated. It's a subsidiary of ASI Incorporated. Morphotek develops novel classes of biological-based products to treat cancer, inflammatory diseases, and infectious diseases. Their original facility and this new pilot plant are both located in Exton, Pennsylvania. Morphotek broke ground for its new 60,000 square foot pilot plant facility in 2010. And the pilot plant was really built for the production of biological-based therapeutics to support early stage clinical trials, which encompasses a current good manufacturing practice, or GMP, grade pilot plant, and supporting office space. The pilot plant supports the manufacturing of advanced therapeutic candidates with either cell culture or microbial systems. With sustainability in mind, and that was a real big driver for this pilot plant, it was built on an existing brownfield site, utilizing a lot of the infrastructure that was from the old facility in the new construction. So green initiatives were at the cornerstone of the development and the design of the construction, and they really drove to minimize the environmental impact while creating a very state-of-the-art showpiece, highly automated facility. So just to give you a quick background, this is when ground broke and the original construction pictures of the facility. As you can see on the left-hand picture there, there's 3 of the air-cooled chillers going up on the roof, which were some of the first pieces of equipment set in place. Some more of the construction pictures. We have some pump distribution on the left, along with the WFI, or water for injection, tank going in on the right. And this is some of the commissioned facility pictures. So on the left there, it's overlooking the utility suite, which housed the chillers, the boilers, and a lot of the very nicely laid out and colored pipe work. And on the right there, that's one of 2 bioreactor suites When I go back, and we'll get into a little bit more about how they wanted this to be a showpiece, you could see on the right there that they had glass walls in between the clean space and the bioreactor suites on the left and the utility space on the right, so that when tours came through, you could really see the whole plant functioning. And we'll get into a little bit more about how the SCADA is represented in that hallway as well. So some more of the project details. This is really focusing around the timeline and awards. So the design originally began in 2008. Construction started in 2010, and then commissioning finalized in 2011 when they're up and running. Total project cost was about $80 million. And as I said, this was a real big showpiece, and they were actually recognized for it. And they did receive a handful of awards. So in 2013, they received the Facility of the Year award in the sustainability category, and that is an award sponsored by ISPE, Interfex, Pharmaceutical Processing Magazine, and Pharmaceutical Engineering Magazine. So some of the key players that allowed them to earn that prestigious award was the fact that I mentioned it was built on a brownfield site. So it was a previously abandoned and contaminated facility, and they went through soil remediation and demolition of that existing facility, reusing a lot of the cinder blocks and building materials they had there. What they couldn't reuse from the facility that was on that brownfield site, they purchased within a 500-mile radius to decrease the transportation and energy that it took to get it to site. They also used building information modeling, a BIM software, which allowed them to make the best sustainable decisions when they're coming up with the design. Aside from the Facility of the Year in 2013, the building and construction and design was certified as LEED version 2.2 Gold. So some of the key factors that played into that certification was the original design was meant to be 33.2% more energy efficient than what's standard to be compliant in a pharmaceutical building. Also, the solar panel system generates just about 100,000 kilowatts per year for the building, which is located on the roof of the building, as well as the water efficiency that was built into the design. It's expected to be about 30% more efficient than the base case to be approved for the Gold LEED certification, and that equated to about 2 million gallons per year that they saved. So some of the design concerns. So as I mentioned, they had an existing plant, which was right across the street from the brownfield facility that they'd be building on. It used a SCADA system that was a little bit dated, but it had the same functionality where it was pulling in disparate processes and utility controllers. But the SCADA didn't really support programming continuity. It was very hard to implement standards, and it was really tough and labor-intensive to justify and track all the changes that were happening for validated and non-validated systems on one SCADA system. So with that in mind, when they went into the design consideration, they really wanted a SCADA package that was flexible enough to incorporate different systems and protocols into the SCADA system while structured and rigid enough to enforce repeatability and electronic signatures and tracing so that it could be changed into and be compliant with Title 21 CFR Part 11. Also, as I mentioned, this was really focused to be a showpiece. So whatever they had in mind, they wanted to be very aesthetically pleasing, and they wanted to have reports and online functionality to be able to bring all the info up for the plant at the touch of a button. So that brings us into the selection process. So originally, the design was that they were going to roll out the same SCADA package that they had at the original facility. Through work of the design engineers, the owner, and our recommendations, the new facility was driven towards a Wonderware system platform solution. And this is some of the real bullet points why that decision was made, and really leveraging what Mike was talking about before. It's really all going back to the object-based programming capabilities. So the first one is that traceable data types for field I/O. So as Mike was mentioning, based off of these object templates, we created the feasibility to create standard templates and derive instances off of each one of those templates, so that once we validated and supported one of those templates, we leverage that for both our site acceptance test execution along with IQ/OQ for the validated half of the SCADA system. So there's also a lot of facilitation for the auditing and electronic signatures for the historical data. Streamlined web interface capabilities. So all the executive staff, as along with the automation staff, even the operations, could log into the info server software and see the exact SCADA screens that were being deployed out to the various interfaces along the plant floor, so they could see what was going on in real time, along with any trends and reporting that they needed to get from the plant. Change control tracking. So what we'll get into in the next couple of slides is there's two SCADA systems, a non-validated and a validated. So change control is obviously important in both of them to make sure that things are being done properly, but the built-in nature of system platform really streamlined the process for having to go in and either create new instances or modify objects, and locking down those attributes, getting it down to the instances where IQ/OQ and change control was really supported, and Wonderware really facilitated that whole process. The other big part of it was that this is supposed to be a fully redundant system, from the controller levels all the way up to the servers and the software. So Wonderware and System Platform had a very effective and proven redundancy strategy that really played nicely into the overall design of the facility. Going back to the vector-based graphics in regards to the showpiece aspect, there was a lot of different monitors and resolutions that were being used for this facility. So there was standard operating workstations or engineering workstations. There was field-mounted panel OIPs, panel PCs that the application needed to be pushed out to, along with that corridor that I was talking about, with the glass walls on each side. We put 60-inch monitors, 3 of them, in the corridor with infrared touchscreen on front of it, and pushed the graphics out to those 3 60-inch monitors, and they had full access for cycling through different screens, opening up different pop-ups. We obviously didn't want tourists to be functioning any of the parameters on the SCADA system, but we did give them full opportunity to open up pop-ups, and the vector-based graphics really allowed for the different resolutions to be accommodated and still keep a very crisp and clean-looking SCADA package. And lastly, the hierarchical process grouping for the alarming functions. So they had remote notification for all of their alarms that were generated, along with historical trends that were generated, and what Mike was talking about the plant model really allowed for us to group pieces of equipment that were related to the same system or subsystem into one area, and that really facilitated putting it into alarming groups and trending groups to come up with unique historical trend default pop-ups and alarming tag structure. So now we'll get into the two SCADA systems. As I mentioned, we had 2 different, one that was non-validated, which supported the utilities and HVAC control, and then we'll get into the validated in a couple slides. So the non-validated portion of the SCADA system was called the Building Automation System, or BAS. So this is the non-GMP system. And here I've broken out some of the points that are incorporated into the SCADA system. It pulled together 3 balance of plant PLCs. It had 12 remote I/O panels. There was 75 variable air volume, or VAV, digital controllers out in the field that had integrated over a proprietary protocol that we needed to integrate into Wonderware. Had 14 air handlers, 7 exhaust fans, modbus communications out to 11 utility process equipment. Those process equipment for the utility system included 3 plant chillers, 3 process chillers, 3 cooling towers, 2 hot water boilers, 2 steam boilers, and 2 heat exchangers, including the ability to move to free cooling. And then more on the SCADA side, there was 3 servers on the BAS, Building Automation System, one development node, one operator workstation, and then 2 touchscreen nodes which were located out in the utility space. And as I mentioned, this was used to monitor the utility section and the HVAC control. So though critical and those serving important pieces are not as critical as a validated system. And on the right here, you could see this is the system status that really gave the operations team and the engineering team the ability to go through and look at the different engines that were running out on the system platform space, along with the PLCs and the workstations, to get a good idea of the network status at any given time. And this was built right into their SCADA screen. So again, some screenshots here. So on the left, this was a redundant air handler system that served a lot of the critical spaces. And as you could see, the system platform software really led to a first-class SCADA package that our engineers put together. And it really allowed it to be a very nice and intuitive SCADA system that could also be shown as a showpiece. So on the left is the air handlers. On the right, that's some of the room controls, some of the reheat coils, some of the information that was being passed back on those VAB controllers, which again was all done via template. So once we developed one system platform, made it very easy to replicate those out to the other 74 different digital controllers out there on that proprietary protocol. So that was the HVAC for the BAS. Now this is the utility side. A couple sample screenshots from the utility side. On the left there, that's the plant chilled water system, and that's the start-stop sequencing control. So this had everything from the chilled water pumps, the condenser water pumps, the priority levels for different chillers, how to switch from free cooling to and increment different levels of free cooling. There also has all the chiller statuses and it's being commanded to run. And this really gave the operations staff a quick glimpse at what was going on out for the utility system as far as the chill water and condenser water was concerned. And on the right there is an overview screenshot of the condenser water system. So as you can see on the top there, it has the 3 cooling towers. It has access and different pop-ups to get to different sequencing screens. Again, the operations staff really liked these comprehensive overview screens to really give them a quick glance at what was happening out in the field. So these are some construction pictures from the utilities aspect. On the left there are 3 of the chillers that were put on the plant floor, obviously before the walls were closed in. And on the right there is some of the distribution piping. So now we'll get into the validated system. So this was referenced as the process automation system, or PAS. So this is the CGMP system. And again, there's 2 PLCs that really govern this, one dedicated to environmental monitoring and one dedicated to the WFI, or water for injection system. There's 4 remote I/O panels. And this system integrated both Ethernet and Modbus protocols, and it went out to 44 pieces of the process equipment. This ranging everywhere from WFI, or water for injection stills, RODI skids, pre-treatment waste kill skids, bioreactors, wave bioreactors. All this needed to be pulled back up. And again, with all these disparate pieces of equipment, but similar in nature, Wonderware really streamlined the ability to create and test an object once, create a template out of it, and derive multiple scenarios off of that, and all having the same attributes, which just really helped with the quality team during IQOQ and writing those protocols. And both from a document standpoint, a programming standpoint, and a commissioning standpoint, it really cut down a lot of the labor that needed to be done, because it was proven that each instance was identical to the next one and identical to the template. So getting into some of the SCADA and the software aspect of it, there was 3 physical servers for the PAS, 1 development node, 2 operator workstations, 5 touchscreen nodes, and those 3 60-inch touchscreen viewing nodes that I was mentioning in the corridor there. And then there was also 19 water for injection POU, which is point of use panels. So the point of use panels were located in the clean space. It gave them the ability to get either hot or cold processed water, which we'll get into in a second, domestic water, instrument air, and other utilities. And on the right there is similar to the BAS that we just went through. This is the network architecture for the PAS. And as you can see there in the black square on the lower right-hand side of that is all of the PLCs that are out there. So all of the controllers that were coming on board with vendor SCADAs or the balance of plant SCADAs. And on the left and on the top there is the different system platform applications that were out there to give operations a good, clean-cut look at what was happening with the network. So this is some screenshots from the process automation system, or PAS. So this is depicting some of the environmental monitoring screens that were happening. On the left there is just an overview of one of the quadrants. So you can see there the building was spread out into 4 quadrants to help with alarming purposes. Again, that plant floor model really helped to collect and organize some of these alarms and data points and history trends. So this is looking at the northeast quadrant which is referenced as quadrant B of the building. So this here you could see where our environmental monitoring sensors were located, breaks it down per room, and whether the room had humidity or temperature sensing in it. Also on the right there's differential pressures through each of the rooms, and that's indicated in inches of water column on the right, and which direction the pressure is focusing in on. On the right there, it's just a magnified view of one of those rooms in there. So you could see this is 4 of the rooms actually. This is what one of the air handlers was serving. So of the 14 air handlers, each one was dedicated to a handful of different rooms. And this view showed this is air handler 6. So what air handler 6 served, these 4 rooms, it gave you the temperature and humidity for each one of the rooms, along with any process equipment that's in there. So as you can see here in this room, there is an incubator. So from the incubator, we were getting a temperature, a pressure, and a humidity. Other things, such as refrigerators, were monitored on the environmental monitoring system as well. So that was environmental monitoring, and this is the WFI system. So WFI, water for injection. So on the left there is the WFI system overview. So that's really the distribution side of it. So we have our WFI storage tank, some of the different distribution pumps that are happening, the immediate flow that's going off, and one of the 5 heat exchangers that were on the WFI system. This was to heat up the WFI. Some set points, and this is also how you accessed a lot of sequencing. Also, there's an interlocks button there that launched a comprehensive list of all the interlocks that were happening in the field. On the right there is one of the 4 cooling heat exchangers. So this took process chill water, and whether the point of use points down there, POU, needed hot or cold water, there's a little set point there above the temperature right next to the heat exchanger. They could adjust it to see if that loop dedicated to that heat exchanger needed hot or cold water, and effectively all drops on that loop would change to a separate temperature set point. And there's different interlocks for each heat exchanger drop, not allowing certain valves to open if another valve was in use, because we wanted to maintain pressure and flow through the loop. Some more construction pictures. So on the left there is one of the Flex IO drops that were utilized for the control system functioning off the controllers. And on the right there is part of the hardware factory acceptance test, or HVAC, happening in our facility prior to the panels being shipped out to site. So some of the customer feedback, again, I think driving the design, going to system platform, originally the customer was skeptical about it because it was software that they were unfamiliar with, but when all was said and done and the project was commissioned, the feedback was extraordinary. They loved the system. It really helped how they functioned, and it helped from the design, programming, commissioning, and just day-to-day operations and maintenance and upkeep. You know, they're definitely happy with the design selection that they made. And this is just, you know, 4 of the different groups of teams that were out there that we were interacting with during the startup and commissioning phases. This is kind of the feedback that I got from them. So from the process automation and engineering team, you know, this was really the team that was going to be taking over the system and making any modifications and going through change control. and really doing the development and programming for any additional ancillary pieces that were coming onto the system. And what they really loved about it was just the standards that were implemented during the design, the objects that were created, and the instances that they derive off of that, transmitters, valves, pumps. Anything they added to the system in the future, they knew that, okay, it's going to have X amount of attributes on it, and we could change it if need be to add certain specific details that this instance needs, but it always knew it was going to be the same and it was going to work. So it really helped in them developing and adding to the system as needed. The quality management department, so really their biggest win in the design was that they separated into two SCADA packages. So there's the validated and the non-validated SCADA packages. So anything that was happening to the HVAC utilities didn't have to go through stringent change control requirements as what was happening to the water for injection and the environmental monitoring system. So having those two different SCADA systems and two different historians tracking really streamlined the quality IQ/OQ process, because they didn't have to go through it as intensely for the non-validated system. So having those separated allowed them to frequently change what was happening on the utilities and HVAC system without having to go through all those steps. And as I mentioned, the pre-qualified templates that we came up with for a lot of these systems really streamlined the IQ/OQ protocols and really helped the validation process. Operations, so with those templates that were derived, obviously we married graphics, as Mike was mentioning with the valve instance. You know, you marry the graphic to the instance, and each, to the template, and each instance that comes off of that template all has the same graphics. So they all have the same pop-up. They all have the open-close functionality. If they had position feedback or limit switches or what have you, they all had the same pop-up and the same look and feel to them. So operations, you know, only had to learn things once and didn't have to really adjust to different unique pop-ups for the different similar valves out there. And then the executive management branch. So the web-based dashboard with info server there, and it really allowed for a quick overview of the system and to check in on things. Also, the vector-based graphics made for a very, very nice showpiece in that viewing corridor that they built. So just some summary and takeaways for this presentation. So the Morphotek pilot plant had those two different separate Wonderware system platform SCADA systems. And it really just helped in the design, commissioning, and maintenance of a state-of-the-art pharmaceutical manufacturing facility. The use of system platform with the historian and info server provided the process, quality, operations, and management teams with a streamlined system, and it really, really supported efficiency in both maintenance and operations. First-class facility, both construction and automation, and it led to being the Facility of the Year in 2013 for the sustainability category. Again, that was sponsored by ISPE, Interfix, Pharmaceutical Processing Magazine, and Pharmaceutical Engineering Magazine, and it was certified as LEED Gold certification for new construction. From this implementation, Thermo Systems really leveraged the experience, and it supported our growth with Wonderware as a partner, and we really got to create a nice template for what we were doing moving forward to support our customers throughout the country and Wonderware's customers. And as an ongoing partnership with Wonderware, we continue to go through training, continue to keep up with the new technologies, and that allows us to deliver the end users with cutting-edge SCADA packages that they're happy with and are sustainable moving forward. So that's it for me. So I'll turn it back over to Kelly and see what you guys, if you guys have any questions.
Great, thank you, Corey. We do have a few questions that have come in. The first one was, were the same object templates utilized for both galaxies?
Oh, good question. So yes, so our standard templates and the galaxies that we deliver with those standard templates, such as transmitters, valving, are derived from a lot of our coding and programming standards are derived. And then if unique ones needed to happen below that level, they were added later. So every transmitter was of a similar template, every flow, temperature, pressure, and then different attributes were added after the base model was qualified. And then anything unique, such as vendor skids, if they were repeatable, so if each chiller or each bioreactor came with the same PLC and programming and naming structure, we leverage that knowledge to make one object and derive instances of it and associate the name of that instance with the physical name of the vendor skid, and it allowed us to just derive objects off of it. So everything in the utilities I'm sorry, the BAS and the PAS were used off of the same general templates, and then we just manipulated them and modified them as needed for both the validated and the non-validated systems.
Okay, thank you. And there's one more. How many IO and historian tags were required to be accommodated for the two systems?
So the exact tally changed a little bit near the end, but I know the original licensing system platform suite that was provided was for both packages was the 25,000 count IO with a 5,000 count historian tag. And there was obviously two instances of that, one for each system.
All right, thank you. And it looks like that is all the questions we have. So thank you, Mike, and thank you, Corey. And if anyone would like to review a portion of this webinar, any portion of this webinar, a recording will be available on our website and on our YouTube channel a little bit later this afternoon. And again, if you can find more information about future webinars on our website. Thank you, everyone, for attending, and have a good weekend.